This video is a continuation of another video, a much longer video that we did where we basically gone through and shown you where the foundation of trigonometry comes from, what's basically the building blocks of trigonometry. So for this unit circle here, we went through in the previous video how to figure out what the coordinate points were in the first quadrant at each of the special angles in the first quadrant. So we are now going to take that and extend it around the entire unit circle. Okay, so if you recall from the previous video, the first angle in our list of special angles is pi over 6. All right, and that coordinate point at pi over 6 was, as we labeled it, radical 3 over 2 1/2. And we went through in the previous video where that coordinate point comes from. All right, so we understand where it comes from. I don't want you to memorize it. I want you to know where it's coming from. All right, and then what I want you to do is we're going to count pi over 6s around the circle. All right, and then I want you to remember that our special angles are pi over 6, pi over 4, and pi over 3. Okay, so the one of those angles that we're going to actually be able to ignore is the pi over 4, because what we're going to do is we're going to take pi. Okay, so here's our pi radians, and we're going to divide it into 6 equal pieces. All right, now mine's not drawn to scale because I'm trying to make sure that I have enough space to fill everything in, but here's my first pi over 6. All right, when I get to when I get to pi over 3, that is the same thing as 2 pi over 6. So that's my second pi over 6. So here's my first, my second, okay? Then pi over 2 is the equivalent of 3 pi over 6s, right? If you think about reducing 3 pi over 6, you do in fact get pi over 2. So I have my 1 pi over 6, 2 pi over 6, 3 pi over 6. So symmetric, 4 pi over 6, okay? And 4 pi over 6 will reduce to 2 pi over 3. I'm literally counting one of them, 2, 3, 4 pi over 6s. But again, 4 pi over 6 will reduce to 2 pi over 3. Okay. All right, keep counting. So we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, pi over 4 doesn't count in there, 5 pi over 6, here's my fifth one, all right, I can't reduce that. And then when we get to pi, right, 1, 2, 3, 4, 5, 6 pi over 6 is just pi. So I've divided my pi radians into 6 equal pieces, all right? And again, that ignores my pi over 4s. So let's just keep counting, all right? So we have 1, 2, 3, 4, 5, 6. The next one will be 7 pi over 6, which cannot be reduced. Okay, we're going to fill in the coordinates there in a minute. Skip the pi over 4, 8 pi over 6. Now 8 pi over 6 reduces to 4 pi over 3. Okay. One more time around. 1, 2, 3, 4, 5, 6, 7, 8 pi over 6, 9 pi over 6, because 9 pi over 6 reduces to 9 and 6 are both divisible by 3. We get 3 pi over 2. All right, then we have 10 pi over 6, and 10 pi over 6 reduces to 5 pi over 3 because 10 and 6 are both divisible by 2. All right, so that's 10 pi over 6s. This is going to be 11 pi over 6, which cannot be reduced. And then we get to 12 pi over 6, which is 2 pi. So it takes us 12 pi over 6s to get all the way around the circle. All right, now we're going to fill in the points. If you remember, pi over 6 and pi over 3 have the reversed coordinate pair. So instead of root 3 over 2 comma 1/2, pi over 3 will be at the coordinate 1/2 root 3 over 2. Now what we're going to do is use the fact that circles are symmetric, right? And we are going to take the first quadrant and reflect it over the y-axis to figure out what these two coordinates should be. So that means the x's that were positive will now be negative x's, but y will still be positive. All right, so instead of positive 1/2 root 3 over 2, now we're going to be at negative 1/2 positive root 3 over 2. So all I have to think about is how symmetry is going to get me to that coordinate. All right, let's take this coordinate. Instead of positive root 3 over 2, we're going to be at negative root 3 over 2 for x. But the y value is still positive 1/2 in the second quadrant. Okay, we're going to do the same thing. So now we can flip this guy over into the third quadrant, but now both x and y are negative. So we'll have negative root 3 over 2. And negative 1/2. I'm going to keep going with the pi over 6. Let's go this way. So we're going to flip it over. Now the x becomes positive again, but y is now negative. So we still have positive root 3 over 2, but now we have negative 1/2. Just going to do a little bit of cleanup here. All right, let's go back to the greens next. Okay, so we've got the first quadrant, we've got the second quadrant, we got to dive down into the third quadrant. Again, this is going to be symmetric. So negative x, negative y, but the same two values. So we have negative 1/2, negative root 3 over 2. And again, I want you to realize that you're not really memorizing much of anything here. You're reasoning out what these coordinates are. All right, and then reflecting over the y-axis, y stays negative, but x becomes positive. So positive 1/2, but we still have negative root 3 over 2. Okay. All right, so those are our pi over 6s, but then I hope you realize you also just unraveled your pi over 3s, right? So if you were going to divide pi units into 3 equal pieces, here's one piece, here's the second pi over 3 piece, and here's the third pi over 3 piece. 1 pi over 3, 2 pi over 3, 3 pi over 3. So instead of 6 equal slices, we have 3. And then to make it all the way around the circle, you would have 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then lastly 6 pi over 3, and 6 pi over 3 reduces to 2 pi. Basically just counting yourself around the circle. All right, now we're going to go into the pi over 4s, which are not related to the pi over 6s and pi over 3s. They're definitely just in between, right? So here is my first pi over 4. Now that means I want to figure out how I'm dividing pi units into 4 equal pieces. Well, here we go. Here's 1 pi over 4. All right, now same idea. 2 pi over 4 will get me to pi over 2, right? Because 2 pi over 4 reduces to pi over 2. 3 pi over 4, we're counting 1, 2 equal size slices, 3 pi over 4. And then the same size slice, 4 pi over 4, right? 1, 2, 3, 4 pi over 4, which is pi. Counting up more, we have the fifth one, 5 pi over 4. Equal size slices, 6 pi over 4, which does reduce to 3 pi over 2. 7 pi over 4 cannot be reduced. and then jumping to 8 pi over 4, which does reduce to 2 pi. All right, now we need to fill in those coordinates that we have here, okay? And these coordinates were your root 2 over 2, root 2 over 2. And so we're going to use that same symmetry to figure out our other points. We're going to jump to the second quadrant, which makes x negative, but y is still positive. So same values, negative root 2 over 2 and positive root 2 over 2. X is negative, y is positive. Jumping into the third quadrant, both x and y are negative. So we have negative root 2 over 2, negative root 2 over 2. And then we jump across the y-axis and x becomes positive, but y remains negative. And this looks like quite a bit of information to try to memorize, which is another reason why I want to remind you that memorization is not actually what you should be doing here. You're whittling out each of these points and each of these angles by understanding what's going on here. And it's all about symmetry and counting your way around the circle with equal size slices, okay? If you wanted to memorize anything, which I don't really like the idea of that, then it would just be the first quadrant, okay? That's all you really need to know. But again, if you can develop the first quadrant from the previous video, then you don't even need to memorize that. All right, and then just a reminder, the sine of an angle is equal to the y value at its coordinate point in the unit circle, and the cosine of an angle is equal to the x value at its coordinate point in the unit circle. Oops, sorry, I didn't mean to leave that up there. So that's just a reminder. So if I were to say, what is the sine of pi over 6? I would go to pi over 6 and find the y value, which is 1/2. If I wanted the cosine of 4 pi over 3, I would go to 4 pi over 3 and look at the x value. So that would be negative 1/2. Okay, so very, very easy to do as long as you understand where the unit circle is coming from. Okay, now, instead of the unit circle, I'm actually going to backtrack to our two special triangles that we developed in the last video. And that's actually where we started the conversation. And that's how we built the unit circle. But the question of how to evaluate trig functions using the special triangles comes back to the unit circle. Okay. So we have an acronym, which I think many of you have learned, SOHCAHTOA. It's basically saying the sine of an angle is equal to the opposite side over the hypotenuse. Okay, so the sine of an angle like pi over 3 would be equal to the opposite side over the hypotenuse. All right, so that means the sine of pi over 3 is root 3 over 2 over 1. So that's just root 3 over 2. Well, let's see. Sine of pi over 3 would be the y value at pi over 3. Yeah, that sure is root 3 over 2. So it works out exactly the same. The cosine of an angle is the adjacent side over the hypotenuse. So if I wanted the cosine of pi over 3, I would look at the side that's adjacent to pi over 3. Okay, see that? That's 1/2 over 1, so just 1/2. All right, well, the cosine again is the x value. So at pi over 3, the x value is 1/2. So it works out. And the tangent of an angle is equal to opposite over adjacent. So we'll talk more about tangent in a later video, but for now, I just want to make sure we're getting somewhere with the sines and cosines. But if you did want to find the tangent, you would go with the opposite side over the adjacent side. Okay, now, some of you may have learned these two special triangles before using different numbers. Well, essentially, this is the scenario where the radius or the hypotenuse is 1, which is the same thing as saying the radius of the circle is 1. Because remember, these angles are generated by looking at right triangles. That was in the previous video, okay? And the radius here should be 1. But you can scale these up or down, right, in any way you want and get a similar triangle with the same angles involved. And for the first triangle, what I'll do is, to scale it up properly, I'll multiply all 3 sides by 2. So if you double all 3 sides, okay, the triangle says the same thing. All right, you have still pi over 3, pi over 6, and pi over 2 for your angles. So you would have a radical 3 for a side, 1 for a side, and 2 for a side. So you may have learned it as 1 radical 3, 2 in a previous class. And that will tell you the exact same thing. The sine of pi over 3 is opposite over hypotenuse. So opposite is radical 3 over hypotenuse is 2. All right. So we're saying that the sine of pi over 3 is opposite over hypotenuse, radical 3 over 2, which is exactly what we said here. The sine of pi over 3 is radical 3 over 2. Okay. The sine of pi over 6, here's pi over 6, is opposite pi over 6, which is 1 over the hypotenuse 2. And if you look back at your unit circle, it'll tell you that the y value at pi over 6 is a half. Okay, let's keep going with pi over 3 and pi over 6 before I come over to this other triangle. The cosine of pi over 3 adjacent over hypotenuse. So adjacent to pi over 3 is 1, if you do the simplified form, over the hypotenuse 2. So 1/2. And then the cosine of pi over 6 adjacent is radical 3, touching pi over 6, right? Over hypotenuse of 2. And again, if you look back at your unit circle, this will align with the fact that sine is y and cosine is x. All right, now for the pi over 4 triangle, to scale this up and make it nice and neat with no fractions, if that's what you're trying to do, you would need to multiply all 3 sides by radical 2, because that would eliminate the denominator on the 2 sides. And some of you may have remembered learning this special triangle as the 1, 1 radical 2 triangle. All right, and then the sine of pi over 4, and I could pick either one of these, I'll get the same result, is opposite over hypotenuse. So 1 over radical 2. Which, if I rationalize that, again, to rationalize, we'd have to multiply by root 2 over root 2. 1 times root 2 is root 2, and root 2 times root 2 is 2. The cosine of pi over 4 is adjacent 1 over hypotenuse, root 2. So there I'm going to multiply by root 2 over root 2 to rationalize, and I get the same thing. Well, that's because if you look at your special triangle at pi over 4, both x and y are root 2 over 2, which means sine and cosine are both root 2 over 2. All right. So now you have the unit circle, you have some special triangles, and I'm going to show you another little trick to help you. This isn't really a trick per se, but it's a nice way for you to develop the numbers that you need to evaluate the sine and cosine at these special angles. So what we're actually going to start with is we're going to list out the numbers from 0 to 4 in the sine row. And we are going to do the opposite in the cosine row. 4, 3, 2, 1, 0. All right. And then, and I'll show you the connection to this, with this to the unit circle in just a moment. We're going to go in and take the square root of each of those numbers. Everything in the table gets square rooted. All right, and then the third thing you're going to do is divide each of those results by 2. So everything gets divided by 2. And then we're just going to simplify them. Okay, so I know that the square root of 0 is 0. And 0 divided by anything is just 0. I know that the square root of 1 is 1, so this gives me 1/2. I can't clean up the radical 2, so we'll just leave this as radical 2 over 2, which doesn't bother me because I've seen that ratio before. Radical 3 over 2, again, I cannot simplify, but again, doesn't bother me. I've seen that ratio before. Radical 4 is 2, and 2 divided by 2 gives me 1. And then basically, because I wrote this in the opposite order, that's exactly what happens down here in the opposite order. 0 over 2, 1 over 2, radical 2 over 2, radical 3 over 2, and 2 over 2, which is 1. So let's go check that against our unit circle real quickly. I want you to notice something. If I said root 4 over 2, right? Root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. Remember, x is cosine. Cosine. Root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. That's exactly what's happening here. The x values, root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. Those are your x values. You're going 4, 3, 2, 1, 0, 4, 3, 2, 1, 0, square root them, divide by 2. That's how you're getting the x values in the circle. The y values just go in the opposite direction. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, square root them, divide them by 2, and then simplify. It's the same thing. But the table's a little bit easier to see because you're not having to try to unravel it. So if I said find the sine of pi over 3, you should get root 3 over 2. Let's check it. Pi over 3 is here. The y value at pi over 3 is root 3 over 2. So yes, we do in fact get the same value. All right, so now you have unit circle, special triangles, or a table. And any of these 3 tools will work when you're trying to evaluate the sine or cosine of one of your special angles in the first quadrant.